What we're going to talk about today is an effort that Liferay embarked on with the OSGi Alliance a little over 2 years ago now. And this is significant for a number of reasons. Because CDI, if you're not aware of it, is becoming more and more important in the Java ecosystem. And I want to kind of elucidate a little bit on that and why Liferay thought that this was an important technology to be involved with. So why OSGi and CDI, right? Why would we go through the effort, take such a large task and try to bring yet another a dependency injection framework to OSGi, which is a landscape that has already other competitors? Well, first of all, CDI is a very important Java specification, as I said. It's becoming more and more prolific in, for instance, Java Enterprise. It's becoming more significant even in Java SC, where the ability to do dependency injection is becoming more the norm, and the standard of CDI is being absorbed as a dependency in lots of other places. For one really good example of that is Portlet 3 upcoming, or the Portlet 3 standard, which was released, that had a very, very tight dependency for a lot of its functionality on CDI. So that was important for Liferay as a portlet implementation. But on even more than that, CDI has a lot of really interesting benefits for us to take advantage of as Liferay, as a platform to deliver functionality to our community. And so we wanted to take advantage of some of those. And but declarative services, right? How many people here know, first of all, what declarative services is? Okay. How many of you have used declarative services in Anger for an application development of any kind? Okay, so a pretty good bunch of you. So if you don't know, if you're one of the people who didn't raise your hand, who doesn't know what declarative services is, it's the OSGi specified way to easily handle the services model in OSGi so that you can compose an application from multiple parts. And if you're not aware of it, Liferay is a huge user of the declarative services since it became OSGi centric. 99%, it's probably 90%, but I just wanted to exaggerate a little bit. It's a huge amount of Liferay bundles or modules, as we call them. Implementation code is based on declarative services because it really enabled us to decompose our application and not avoid a lot of boilerplate, a lot of repetition, but also enable a lot of different behaviors and functionality that was needed to be custom back in the day. So just to be very, very clear, even though we're talking about a new specification for dependency injection, the goal is not that Liferay will replace its use of declarative services. That's never going to happen. We may take advantage of it. We want you to take advantage of it, but it has very specific use cases or very different kind of use case requirements. So when Brian Chung was doing his keynote, or Brian Chan was doing his keynote this morning, and he said the portal starts up in 35 seconds and he wants to go down to 15 seconds, it's declarative services that's going to enable that. So we definitely don't want to take that away. And if I'll talk a little bit, or if you know a little bit about CDI, you understand that there's quite a different model there. Declarative services is super lightweight, right? It has a very low memory footprint. It's very, very fast. It has a low amount of friction with the code. It uses the least amount of reflection that you could imagine. So it's very, very, very fast, very, very efficient. And when you look at declarative services, how many people have used declarative services XML files? I'm really glad to see that, okay, one person has, but I'm really glad to see that no one has, but very few people know that declarative services is actually an XML-based runtime. But when we consume it, we are always using these nice annotations that give us this power and this flexibility to describe what we want to do with our application. But those annotations are class retention. What that means is that they're not really a dependency at runtime. So they're not visible through a reflection. So that just means that we use a tool to get from the annotations at build time to the XML at runtime. And you don't have to look at any of that, and that's really, really nice. But one of the differences and one of the advantages that CDI will bring over declarative services is that I often hear developers saying, oh, can we add another annotation that means this other thing into our declarative services components? And I have to answer no, because fundamentally declarative services isn't an annotation processing engine. There's a tool that does this translation at build time, but DS is itself as a runtime, it can't do more than what it was initially designed to do. That's actually the design by rote, right? So CDI as part of its feature set is extensible from the beginning, from the ground floor, right? And it's really an annotation processing engine on top of many other features, but that is one of its key attributes. And we want to take advantage of that. And we can do things like custom annotations. There was a couple of different talks today that talked about using annotations to do things in Liferay that made it nicer. I think Mimicom's talk had Extivia annotations, and they were doing permission checking through annotations instead of through prescriptive code or through imperative code checks, right? And that's really, really nice. It makes things very elegant. It makes it easy to consume new functionality. So custom annotations will be enabled through the use of CDI. So if we wanted to do some of those things, we would be able to have that route available to us. So, and the other major thing that CDI gives us is the ability to have private internal wiring, which I know a lot of people feel is desirable, and it is desirable in a lot of cases, and a lot of reasons why people use Spring in the first place is because they can have a fairly complex object graph of their application, but the wiring is done, inside, hidden in the application, but there's still some kind of breakdown, dependency, inversion of control, dependency injection there. That's happening, but it's private. And that's very powerful, so CDI enables this. So DS, right? If you want to wire things inside of your bundle, you have two options, but the real way that a DS expert would say, how do you do your internal wiring? Well, you basically use new. That's what they would say. But we understand that that's not nice. We like these reference annotations. We like these service annotations. And we often have two components inside of our bundle, and we want to wire them together. So we use a reference annotation. But what does that do, really? In reality, that exposes your application to the OSGi service registry. And even though the classes are private inside your bundle, there's still a reference in the OSGi service registry about that, and some other bundle could come along and reflect against that service reference and see what's happening. Now, it's not usually a big deal, but it does cause a little bit of overhead in the OSGi framework, and if you could have a more complex wiring that's hidden inside your bundle, then you wouldn't have that. And there's other benefits as well. So, CDI wiring, if you ever used Google Juice, or if you've used Spring annotations, you might recognize the @inject annotation, which is a specification of its own. It's called Dependency Injection for Java. And it's been around for several years, and it's the foundation of CDI. it's the user interface of CDI. You use the inject annotation to inject some object. It comes from some context inside your application, and yet the isolation of your wiring is still inside your bundle. So it's really nice, it's elegant, it's clean. It avoids a huge amount of boilerplate. So this is a basic bean with a basic injection point. So then we move forward and we want to go to the next level of the OSGi interaction. So now we have CDI, we have all our beans, and if you know, I recommend to look at the CDI specification to see what the benefits are. Maybe you know it already, but if you don't, you can do the similar thing that you would do and expect to do in Spring, right? All this inversion of control and dependency injection. So here we're moving on to the integration with the OSGi registry, which you get with Declarative Services. So here, the typical thing that you do in Declarative Services is create a component, and you want to register it in the service registry. And here I just took a very basic example. There's no interface. It's just publishing the raw class into the service registry. And so that's what it looks like in Declarative Services. So doing the same thing in the CDI integration is very similar. We have an @service annotation on a particular bean type, and that's how we do it. It will automatically take the implementation type as the service type. Very nice. Now, there are multiple different scopes at which you use OSGi services, right? There's the singleton model, where you create a service in your bundle, you publish it into the service registry, and everyone that interacts with the service registry and gets that service reference, they all get the same instance. So that's the singleton, right? However, there's two other modes. There could be every bundle, every individual module that asks the service registry to get an instance, gets a different version, a different instance of the service, right? So they can have bundle level isolation. But then finally, there's prototype scope, which is very useful in a bunch of different scenarios where you want to get a brand new instance every time you call for it. And this is a prototype scope. And this is how you would do it in Declarative Services. So you would say scope equals prototype, and then whenever that's requested, you get a new instance. So in CDI, you need to be able to do the same thing. So here we register the service, but we're saying the service instance we want back should be prototype scope. So there's parity here. Now, we have DS references, right? The references in DS are how we consume services from the service registry. We looked at how to put services in the service registry, and now we want to get services from the service registry. This is interacting with your whole framework ecosystem, right? This is how Liferay enables all of its functionality is through the service model, and this is how you consume a service. Just an @reference annotation, and here is a simple example, just a mandatory reference for this type POJO. So in CDI, it's virtually the same, except CDI already has this concept of that inject. We need to qualify that injection point to be also a reference, so that this is the way that you tell the CDI injection point and the CDI container, I want a service in this injection point. So cardinality. Cardinality is when you're dealing with, the different number of services that match the type that you're looking for, right? So here we have a mandatory single cardinality reference. Pretty obvious. I just want one reference, one instance of the type POJO. And I'm just going to operate with that one forever. And in CDI, that looks very similar. It's just the same one that I showed earlier. It's just @inject, @reference. You get mandatory requirement. What mandatory means in OSGi and Declarative Services is that if you deploy the bundle and you start the bundle, if there's nothing to provide that reference, the component won't start. So it's waiting passively. which is really nice model when you want to have, when you want to trigger the logic of your application based on the state of the system. So the next level is an optional cardinality reference, right? You might not always need that. You might be able to operate without it there, and so you want it to be optional. So in DS, this is based on more information on the reference, right? You're just saying, I want this reference to be optional. Now, what we're talking about here is that this field could be null, which is, you can deal with that. It's not terrible, but you have to do an if check. And since we were learning from what Declarative Services had when we were building CDI, we said, well, maybe there's a slightly better way to do this in CDI. And so we leveraged the type system to do a lot of these functionalities that the type system that Java has naturally to be able to deal with these particular scenarios. So in CDI, when you have an optional reference, you literally use a Java optional, which is really nice. You don't have to do any null checks. You can just check the state of the optional, right? This is much more elegant. And you don't have to have a more verbose annotation. It's just directly based on the type. And multiple cardinality. Multiple cardinality, if you've ever used that, it's very useful when you have multiple. This is like the listener model. You have multiple listeners and you need to iterate over them, something like that. You want to get all of the implementations that are in the service registry, and you could do this in DS just by having a field of type list of the service type that you're interested in. Very nice. CDI multiple cardinality is the same. @inject, @reference, list of POJOs. So DS, moving to the next level of cardinality, you want to have a little bit stricter control over the number. And one very popular use case, or more common use case in DS, is to have at least one service in the list in order for me to start, right? So don't start me until there's at least one. That's what this is saying. So again, you have the annotation. It's a little bit more verbose, but it's still a list, and that is populated for you when it's available. So then in CDI, we still want to be able to have this at least one. The difference with CDI is that in DS, if you wanted to do at least 3, you'd have to go to configuration to apply some DS-specific configuration properties on the component to say, it's not at least 1 that I want, it's at least 3, but you can do that. In CDI, you can actually express this directly because there's no explicit at least 1. It's just we have this annotation that lets you put your minimum cardinality there. So you can say at least 2, at least 3, at least 4, at least 5 right in your code. It's much more. But you can still override this through the configuration, however. But you can't go less than what the minimum says, just to be clear. So then, greediness. How many people who have used DS in anger have realized after they wrote their code and a month later that the reference policy is reluctant, which means that when they put a new service into the registry, the component that had a reference didn't see it? You might have tried to integrate with Liferay at one point, and what you did is you followed our documentation and you said, oh, I want to create a new implementation of that URL parser thingy, and I want to deploy it, and it should just pick it up because that's how OSGi works. Except that the developer who created that reference didn't use greedy, and so it was reluctant by default, which meant that it's going to just stop looking in the registry after it finds one that matches, and then it's never going to look again. So greediness versus reluctance. Declarative Services is reluctant by default, but you often want greedy. So you have to specify it. CDI learnt from this and realized, and most people realized, we probably want the opposite. In most cases, we want things to be greedy because we expect that when we change the service ranking on a service, that's the better one, and it should just get picked up automatically, and we shouldn't have to go an extra mile to get that behavior. It should be the default behavior. So we did that because we learned from DS. So in CDI, you're greedy by default. But if you do want reluctant, you can add the reluctant annotation and get the behavior that DS has by default. Dynamic mandatory. So in DS, if you have a reference and you want it to be dynamically updated as you're running, as your component is alive, then you need to make that field, in this case of field injection, you need to make it volatile. Otherwise, you're not always going to be able to see the correct state of that field if you're particularly in a multi-threaded environment, right? DS also use the type system to get around that problem because CDI already has, or rather inject specification, already had a type equipped to accommodate for this particular scenario. It's a provider, it has one method, it's just get, and so it's guaranteed that whenever you call the get method, you're going to get something. It's never going to return null. It's always going to be a thing. So that's very convenient. Multiple, you have a list of POJOs. In DS, if that's dynamic, you need to make sure it's volatile. There's other ways to deal with this, but this is the simplest way. You're just going to get replaced with a list, so you need to make sure that you always get that list and reiterate over it. In CDI, we solve that again through the type system. We just say, okay, just give us a provider of the list. I don't care. I'll just do the get on and then get the list and then operate it on. I'm sure that I'm always going to get the updated one. It's a little more elegant. So here, if I wanted to do dynamic optional in DS, I have to get even more verbose with the reference annotation. And in CDI, again, I'm just using the type system, provider optional of my service. At the end of this, it's very convenient. Often we need loggers. DS added this in the most recent version, so if you're using Liferay GO2, you can actually just inject a logger instance into your components, which is much nicer than using a static singleton. You get a unique one for your component. This is a really nice feature of OSGi now. The OSGi logging API is much improved in this release, in this newest form, and so it is in Liferay as well. The logger API is based off of SLF4J, so you get all of the replacing options, much better string manipulation, just a much more elegant API, and it's familiar for all the SLF4J adept here. And in CDI, we went the extra step even further when we said, let's just make it really, really easy. So now you just inject a logger. Boom, you're done. You carry on with your work. And configuration. Configuration is super important in OSGi. We have all these bundles. They all have different sets of subsystem code and logic that they all need to be configured. We need to be able to target them. The typical way to do that in DS is to have an activate method that receives the map of properties, and then we can either actually in the newest version of DS, you can actually use a type, an actual type as the argument of the method, which is an annotation, and the map will be coerced into that, so you get type safety, but you still have to have this activate. These are two different ways of doing configuration, of receiving the configuration in your component. The activate method or an activate field. Activation fields were added in the version of DS that's in GA2. So that's really nice. In CDI, we need to be able to do the same thing, but it's on top of the injection model. So we have @inject, component properties, we get the map. So moving on to the next layer, so we have the services, we have references, but the really cool thing about DS is that we have a bundle with multiple components in it, and they have an individual independent lifecycle from one another, right? That's part of the dynamism that you get from OSGi. It's part of the dynamism you get from Declarative Services. It handles a lot of logic from you. It lets you signal on services instead of on method calls, which is really nice. That's a very elegant model. And so we built that possibility inside of CDI. So the blue part here, I don't expect you to be able to interpret all of this. I probably went a little crazy. This is my standard CDI application. The point here is that I have a class, I have another class, I have another class. These are all kind of wired together through some annotations. That's kind of like what your Spring model is, right, for dependency injection. I have a complex thing built from many classes. That's the point. They refer to each other. There's a reference here. Now I'm pulling in the OSGi part, right? Okay, one of these things has to be a reference, which means I want a service from the service registry, another list of references, and so on. So this is all one unit. This is what CDI traditionally looks like. And it lives as a single entity, as a singleton, right? So if this reference here isn't available, if there's no configuration admin, the whole thing cannot live. This whole thing cannot start, right? But that's not very dynamic, is it? That's like, okay, you're missing a reference or some reference goes away. I have to tear down the whole application. I have to tear down the whole CDI container. But it's a limitation we have to live with. And so, but CDI is also very clever in that it gives us a lot of space to enhance it. And so we have the traditional model, the traditional side of your application, and then we have the ability to create scopes that have their own, that describe their own life cycle. And so the CDI specification was able to say, hey, okay, we create a new scope that's going to be in line and react to the changes that are occurring against the configuration and the services as they come and go from the service registry separately from the main body of the application. Now, this is Declarative Services over here. This is the exact model that Declarative Services has. This component lives in complete isolation from these other components. We have factory components, so we can create multiple instances of them based on different configuration instances. We have a single component. This is the model where it's a single configuration targeted at a particular component. This is your 99% of your components right here. That's what it looks like in CDI. And yet you can still inject references. You can still have this graph of objects can be complex, can be made up of 100 beans. And every time if this is a service, this guy here is a service. He's a factory, so every time he gets into the service registry, this whole bean graph gets recreated, a new instance of it, and given to whoever the caller is, depending on what the scope of the service is. So this is DS in a nutshell. The really cool part is that if that's all you're looking for, this can be completely empty. It doesn't need to exist. You don't need anything here. It could be completely empty. And then what your bundle looks like, or your module looks exactly like DS. Exactly. Behaves exactly like DS. Individual components on an individual life cycle based on configuration or on the services that are the dependencies, which is really nice and elegant. But if you're just ramping up and you have a traditional CDI application and you just want to drop it in OSGi and have it work, boom. This is this is what it looks like. This is what it is. You don't need any of these service references. This is just pure CDI. You get it from some bundle somewhere, some artifact in Maven Central. You drop it into the OSGi runtime, and this works the way that you expect it to work. Oops, sorry about that. So this is configuration policy for the component in, so the component in DS. This is what it would look like if you wanted to configure it. This is kind of an extreme example, but just to show you it's pretty powerful. This is what it looks like in a single component in CDI. And this is a factory component in CDI. So you have the two different models. And can I see the spec for this? Yes. It's online. OSGi.org specifications in HTML. You don't have to download a PDF. You can thank Liferay for that because we did a lot of effort. And then finally, can I try this thing out in Anger? You can. It's a project at Apache Aries that Liferay is the maintainer of. And you can get it and you can use it. You can drop it into your OSGi container. And that's it. I hope you have questions for me at some point in the rest of the event. Please rate the session, and I hope you enjoyed this.